these are some functions. Let's find out what is its domain and what is its range of this function. Now remember, what is domain? Domain means what? All input values of x, and then it should define the function. Okay. What about range? Okay, remember the range are all outcome values of x which is defined. Let's see this. What about this example B? Say f of x over here equals to x square. Now let's say x and f of x, or you can say x square. Now here this column is what? I'm going to input, I'm going to assign values of x over here. Okay, that's called what? Domain. So can I assign 1 over here? Yes, I can assign 1. If I assign 1 over here, then these functions gives real value. Okay, so if I substitute 1 over here, 1 square is same as 1. Similarly, can I substitute 0 over here? Yes, because 0 square is what? 0. Can I substitute minus 1 over here? Yes, minus 1 whole square is same as what? 1. Similarly, if I can take 2 square is what? 4. Similarly, if I assign minus 2, then it's become minus plus 4. Now, these are what? These are inputs of x. Okay, therefore, the domain of this, okay, here domain of this is equals to what? All real number, all set of real number. For all set of real number is the domain for this fx equals to x square. What about range? Let's see how to find range. Let's see. In order to find range, let's draw the graph so that we can have clear idea. Let's consider this is x and this is y axis. Y-O, y dash, x-O, x dash. Look at this coordinate. We can call this is what? 1, 1 over here. So let's trace x-axis up to what? 4 points plus. Here we have 1, let's say 2, 3, 4. 1, 2, 3, 4. In the minus, let's trace 1, 2, 3, 4. Here minus 1, minus 2, minus 3, minus 4. What about y-axis? Here also let's write 1, 2, 3, 4. 1, 2, 3, 4. Here also let's say minus 1, minus 2, etc. Let's draw this column in x-axis and this is in y-axis. Okay. Therefore, 1, 1 is what? Here, if I am going 1, 1 is over here. This is 1, 1. 0, 0 is over here. 0, 0. Minus 1, 1. So, x is going minus 1, y is going 1. Plus 1 over here. And then here 2, x is going 2 and y is 4. X is going 2, here y is what? 4. And then x is minus 2 and then y is what? 4. Okay. These are the all points. Okay, let's make a dotted line like this. It is called what? It is called what? Parabola. Upward. Okay. So now for every, okay, look at here, for every values of x, you will get its image over here. Okay. For example, if you have anything, you will get over here. Okay. So if for every points you substitute over here, so you will get its image over here. Okay, its output over here. So if I give some input over here, you'll get some output over here. Okay. So therefore, for every values of x real number, for input you'll get its image or its output into the particular function. Okay. Range is what? Range is all values of y, all values of y greater than equals to 0. Range equals to all values of y, all values of y which is greater than equals to 0. This is y, right? This is y. All values of which is greater than equals to 0 means over here 0. 0, 0 satisfies over here because we have 0, comma 0. So all values of x which goes up. Okay. This is the range for this function. Okay. Let's see fx equals to what? X minus 2. What is domain? Domain means what? Remember all inputs of x which should be defined. If I substitute x equals to 2 over here in this denominator, 2 minus 2 become a what? 0. Therefore, the 1 by 0 is what? Undefined. So, the function is not defined. So, you are not allowed to choose or you are not allowed to assign x equals to 2 over here. Therefore, for domain, denominator should not be equals to 0. For rational functions, rational function it is from here p by q where q is not equal to 0. For rational functions of say for example px upon qx, there here qx should not be equal to 0 means this denominator should not be equals to 0. Okay, for the domain. Okay, this is what for domain, right? For domain, this denominator should not be equals to 0. So you can choose any real number, but this denominator should not be equals to 0. Let's see. For example, I have x, f of x, or you can say this is 1 upon x minus 2 or okay. Let's substitute and let's draw it is in x axis and let's draw this is in what? Y axis. And for example, if I substitute x equals to 1 over here, 1 upon 1 minus 2 is what? 1 minus 2 is minus 1. Okay. So my 1 upon minus 1 is I am getting what? Minus 1. If I substitute 0 also over here, okay, now I am getting what? Minus 1 by 2. I cannot substitute 2 over here. Why? Because if I substitute x equals to 2 over here, these functions doesn't define. In order to find domain for this type of rational functions, this denominator should not be equals to 0. Okay. Therefore, I cannot choose x equals to 2. Now, can I choose x equals to what? 3. If I substitute x equals to 3 over here, 1 by 3 minus 2 is what? 1. Okay, therefore 1 by 1 become a 1. Now, let's take another. What about 2? Okay, let's see. What about minus 2? Minus 2 is what? Minus 4. So, I can write it is defined. Therefore, it is minus 1 by 4. So, I can take another number, for example, 4 over here, okay? If I substitute 4 over here, 4 minus 2 is what? 2. Therefore, I am getting half. For this function, fx equals to 1 by x minus 2, what is domain? Okay. Therefore, domain is all set of real number, all set of all real numbers. Okay. But you cannot take this particular element 2. Means r minus element 2. Means you can take all set of real number, but you cannot take 2. Okay. Therefore, we can define domain of this function as real number, set of real number minus this particular element 2, neglecting this 2. Okay, it is plus 2, but for minus 2 we have defined value, so we can take minus 2. Okay, so therefore the domain of this function is r minus 2. In order to find its range, let's draw a graph and let's see how it works. What is the nature of the graphs? We'll come to know, and we'll find out its range. Y, and this as a x axis, Let's consider this is y axis and this is x axis, x of x dash, y of y dash. Now here the maximum values of x is what? 4. So I can write 1, 2, 3, 4, 1, 2, 3. Minimum values of x is -2. Here 1, -2, say -3. And this column I am considering as a y. Okay. So all is starting from -1. Say let's say -1, -2, here 1, here 2, here 3. Let's plot these graphs so that we can find each range. Now what is 1 comma -1? Here x is going 1 and y is -1 over here. So this is the point over here. So this 1 comma 1 is over here. 1 comma -1 is over here. What about this? 0 comma x is not going anywhere, but y is -half. So we are getting over here, okay? This point. And here x is going 3 and y is what? 1. X is going 3, x is going 3, y is going +1 over here. So I will write over here like this. And then here 4. And then what about 4? 4 comma half. X is going 4 over here. And then it's what? Half. Now this graph is, now we have this point. Now let's see what is these functions, okay? Now this function can be written as, if I rationalize numerator and denominator by x plus 2 and x plus 2 numerator and denominator, what we get is what? This is what? X plus 2 upon x square minus 4. Okay. This is what? This is quadratic equations. Okay. This is what quadratic equations we have. Okay. So this is not a straight line, I mean to say. Okay. This is not a straight line. Here we have like this. Okay. The curve goes something like oscillating like this. Okay. Here it goes minimum at -1 and it goes maximum at 1. Here we have, here this line is what? Y equals to 1, and this line is what? Y equals to -1. Therefore, whatever the value you give, okay, so it lies in between -1 and +1. Therefore, we can say that for this function, okay, for this function, domain is this, range is equals to, including what? +1 and -1, including, here you can say 1 comma -1 close interval. Let's see this function f(x) equals to what? Square root of x minus 4. Remember here we have square root. Inside square roots you are not allowed to get minus sign, because square root of minus is what? It's imaginary number. It's I. We call it's I. So it has different chapters. We call complex number. Here we will consider finding domain and its range of a functions with respect to its real valued functions. Therefore, we are not allowed to take complex number or imaginary number over here. In order to get these positive inside square root, I should get what? I should get this x should be greater than or equals to 4. Why? So that I can get the values of f(x) as a valid answer. Therefore, for this f(x), for this domain, what? Domain is set of all real number, but okay, but which should be greater than or equals to 4. You cannot take the number which is less than 4. If you take those number which is less than 4, then these become what? Imaginary number minus of I. That's complex number.